Hello. So this week lab, you're using a bending light simulator available on the PET simulators. So when you're opening the simulator, the page should look like the one over here on my screen. In this one, we are going to use the intro portion of the simulator. So click on the intro and it will open you to a simulator like this one where you see a light and some other options. So in this lab, we need to use the, not the wave quality, we like to have it as a ray. And when you switch on the laser light, it's shoot a red color laser light. And then we can change the medium where the light incident and get refracted or reflected as well. So here, if you go to the material, whatever the top material over here in the first region is air here, but if you click over the drop down menu, you may change it to a different medium. So let's say I want air, so I will keep it as air. Now in the second medium where the light incident from the air, and let's say it's entering into glass, so I want to make the second medium is glass, so I go to the material and I change it to glass. So now I have glass on as the second medium over here. So the incident light rays enter into glass here. So this represents the refracted beam, and here this is the reflected beam. And over here we have an option that we can use the protractor. So if you drag that one, and you can even move it here and there. Let's say I want to measure the incident angle and the refracted angle. In that case, I want to align this protractor, the center point, at the place where the normal crosses the medium, right? And the light ray or the laser ray also incident on that point. So I need to keep the center of the protractor at the place where it crosses the medium border and the light, the red light, and the normal. So here I keep it sharp like that. So make sure you keep your protractor properly, otherwise your numbers will be way off from the real value, right? So after you keep it like that, you see like 0, 0 line is going through this normal, right? So 0, 0 goes through this normal, and 90, 90 line will go in the the glass and air border here, right? Then let's say I want to change the incident angle. So let's say I want to incident a light ray at a 30-degree angle. So I'm shooting the light ray through the 30-degree. So here I'm measuring my incident angle from the normal to the light ray, right? So this is the incident ray and that's the normal. So this angle is 30 degrees. Now let's say I want to read the reflected angle. In that case, I need the angle from the normal to the reflected light ray. Here, I would read it as 30 degrees. So it's good, right? So the incident angle is equal to the reflected angle. And here, this is the refracted angle. So in this lab, we are mostly interested on the reflected angle here. Now, the reflected angle, I would read it as 20 degree or little lower than that 29 degrees about, right? So you can zoom the screen and read a really good number here. Read it closer to the values that you can observe, right? So that will give a uncertainty in our experiment. So you might observe a percent difference in your theoretical value and the calculated values depending on how you're good at reading this protractor here. Now, if you're interested to see like how much light get reflected and refracted, you can use this intensity reader. So the here, if you keep it on the incident beam, it is 100% intensity, and the refracted one is about 94%, and then the reflected beam is about 5.81. Right, so actually in the lab I didn't ask you to use the intensity meter, but if you're interested, you may use that. Now let's say I want to observe the internal reflection, right? So in this case, I need the light to be incident from a denser material to a lighter material. So I need the incident region to be denser than the second medium. So I want to change the first medium to glass, so I can change it to glass, and I can change the second medium to air. Let's say I want to make it denser, lighter material as air. Now here, by dragging the laser light, you can change the incident angle, right? So here it's 0, it's going through the normal. Now I'm increasing this angle until it's get totally refracted. See, that's the border, right? So in that point, right about there, the light get internally reflected, right? So in this case, if you move it a little bit, that's the border. So you may play with the simulator to see like whether you can make it go along the border where it's separating the glass and air, right? So somewhere there. So you may read this angle. So you see like 100% of the light get reflected, right? So this is called the internal reflection. So if you can measure this incident angle, that's going to be the critical angle. So I would read it as 32 degrees in my measurements. However, the refracted angle is going along this line right before this angle occur, right? So let's say 31 or in between 32 and 31 degrees, right? So let's say 31 and a half. So at 31 and a half, the refracted light is going along the glass and air border. So here the refracted angle is 90 degrees, right? Refracted angle is 90 degrees. Incident angle is about 31 and a half, right? So roughly, let's say 32 degrees, right? So 32 degrees, that is the critical angle, and the refracted angle is 90 degrees here.